Welcome to today's Explainer. We are jumping right into a concept that is quietly, but completely, changing how we interact with artificial intelligence. Today, we're stepping inside the Core Lab with Dr. Ed Pearson III. He's an associate professor of computer science to unpack his fascinating lecture on advanced prompt strategies. Specifically, we're going to explore this massive transition from treating AI prompts like, a quick text message, to treating them like a highly structured architectural blueprint. We are talking all about few-shot prompting. So, let me pose a quick question to you. Why do these incredibly advanced, frankly brilliant AI models so often just fail to follow our seemingly simple instructions? You ask for a specific format and it spits back a giant wall of text, or you ask for a data-driven health analysis and you get these generic, empty platitudes. Well, it turns out relying purely on instruction-based logic, what computer scientists call zero-shot prompting, often falls completely short when we need outputs that are structurally consistent, verifiable, and ethically grounded. Basically, to get the machine to think correctly, we have to entirely change how we teach it. Here is our roadmap for the Explainer today. 1. Showing instead of telling. 2. Engineering high-quality examples. 3. The context window cost. 4. Amplifying bias at scale. And finally, 5. The few-shot blueprint. We're going to cover both the hard technical mechanics and the absolute vital ethical frameworks of AI prompting.
All right, Section 1. Showing instead of telling.
Okay, so this is the core paradigm shift. A zero-shot prompt relies on instruction only. You just give the AI a command, like identify a structural barrier for Madison County, Alabama. And the result? It tells you lack of insurance coverage is a barrier, and maybe suggests Medicaid expansion, which is technically true, but it's incredibly weak. There are no specific stats, no citations, and zero equity framing. But notice the few-shot approach. Instead of just telling the model what to do, we show it exactly what success looks like. We provide two beautifully constructed examples first, maybe one about Jefferson County, another about Houston, complete with precise data and exact citations like ACS 2022. When we finally give it that Madison County task, the model just naturally mirrors that high standard. It encodes the format perfectly.
Moving on to Section 2. Engineering high-quality examples.
You see, these examples aren't just polite suggestions, they function as a strict algorithm. Dr. Pearson outlines a really precise 5-step sequence for building a few-shot prompt. Step 1, choose your exact target format, right down to the bullet points or table columns. Step 2, match your equity lens. You absolutely have to use real communities. Step 3, include verifiability. Show it actual citations. Step 4, vary the examples. 2 identical examples just teach the model one specific case, but varied examples, that teaches it the underlying pattern. And step 5, this is absolutely critical. Always place your examples before the actual task. The model reads sequentially, right? So if you put your question first and the example second, the whole logic breaks down. The task itself must be the final thing the AI reads.
So the crucial takeaway here is that every single example acts as a binding contract between you and the machine. It absolutely must encode 4 pillars. First up, format precision. If you want a 2-column table, show it a 2-column table. Second, equity and specificity. If you use vague, abstract terms like low-income neighborhoods in your example, the model will just spit back abstract, placeless outputs. You have to name real communities. Third is the verifiability standard. Literally show it what a proper citation looks like. And fourth, length and depth calibration. If your example is just 2 sentences long, the AI's output is going to be 2 sentences long. You are literally calibrating the machine's behavior through demonstration.
Section 3. The context window cost. Now you might be thinking, well, why don't we just give the AI 50 examples so it's perfectly accurate? That all comes down to the context window. This is the maximum total text a large language model can process at once, and that includes both your prompt and the generated output. In computer science, this text is measured in tokens, and tokens cost real money and serious compute power. Every single example you feed the model eats into this finite, incredibly expensive resource. If your examples are too long, you literally leave the AI no cognitive room to actually analyze and complete your final task.
Notice the focal point here. 2. In practical prompt design, there's a very real quality-to-cost trade-off. Dr. Pearson notes that for most research tasks, 2 high-quality, perfectly varied examples are totally sufficient to establish a pattern. 2 highly refined examples will beat out 5 mediocre, rambling ones any day of the week, and they will save your precious context window and token limit.
Section 4. Amplifying bias at scale.
So how does all this tie into the systemic ethics of prompt design? Well, few-shot examples are never truly neutral, which brings us to a terrifying little concept called scale amplification. This is a systemic error where a biased example in your prompt shapes and infects every single generated output. Think about it for a second. If you built a prompt to analyze 100 different census tracts for maternal mortality gaps, and the two examples you provided to teach the model were flawed or biased, that error isn't just local anymore. It is systematically multiplied 100 times over. The stakes of what you choose to show the model are incredibly high.
Dr. Pearson points out 3 specific ways our examples can quietly introduce this kind of bias. First, example selection bias. If your examples only feature wealthy, well-resourced communities, the model learns that this is the quote-unquote default normal, and it's going to propose wealthy community solutions for everything. Second, stereotyping by omission. If your examples mention poverty but completely ignore historical context like redlining, you are teaching the model to produce historically ignorant outputs. And third, citation authority bias. If you only show examples that cite massive federal datasets, the model learns to quietly discount community-based research or lived experience data. What you demonstrate is exactly what you get.
Finally, Section 5, the few-shot blueprint.
Bringing all these mechanics and ethics together, here is what a fully engineered prompt actually looks like in action. This is the root cause analysis table exactly as it appears in Dr. Pearson's source material. Notice the strict columns: cause, evidence, equity impact, and verifiable source. By putting this exact table format filled with real data like 3.7 times the national average and specific equity impacts on Black households into the prompt as example 1, the model is locked in. It has absolutely no choice but to adopt this rigorous, data-heavy, equity-focused format when it finally gets to your task. Formatting your demonstration this clearly guarantees a structurally perfect output.
But here's a crucial piece of practical advice to keep in your back pocket. Strip your examples before publishing. When you generate that amazing final table or report, those few-shot examples you use to train the AI, they're just scaffolding. They are not your final content. You absolutely should document them in your methodology so people know how you did it, but you remove that scaffolding before presenting the final deliverable to a policymaker or a community board.
I want to wrap up our explainer today with this really powerful quote from the lecture. The goal is not to use AI better, it is to think better, with AI as your instrument. The machine is not the architect here, you are. The machine is just following the blueprint you draw for it. If your blueprint is highly detailed, ethically grounded, and perfectly formatted, the building is going to stand strong.
So as you go out there and engineer your own examples, I want to leave you with this provocative thought to chew on. Look closely at the examples you are feeding these machines. What subtle biases are secretly encoded in your next prompt? Are you defining the default world accurately, or are you just amplifying a blind spot? Take a hard look at your blueprint. Thanks so much for joining me on this explainer and keep learning.